You know that feeling when you're sitting in math class and you have no idea what the teacher's saying? And when you go home and study, it's really boring and there's absolutely no breaks? Now introducing the Calculus Cooking Channel, where we'll teach you calculus and how to take a break and cook. Welcome to the Calculus Cooking Channel.
Our first big concept is that a function defined as an integral represents an accumulation of a rate of change. So what is a definite integral? Definite integrals replace the need for the constant c in an indefinite integral. Definite integrals can be utilized to represent the area under the curve. Integrals can be used to find area and volume, representing an overlap between calculus and geometry. As for the notation, the area of the region is bounded by f, the y-axis, and the lines x equals a and x equals b, which are the limits of integration. A common misconception that some people have is that definite integrals can be written going from bigger to smaller limits of integration. However, they must be rewritten from smaller to bigger values with the negative sign taken out. Now for the baking. We're going to have to gather our ingredients. We're using half a cup of vegetable oil, 1 cup of sugar, 1 teaspoon of vanilla, 2 large eggs, a 1/4 teaspoon of baking powder, a 1/3 cup of cocoa powder, a 1/4 teaspoon of salt, and a 1/2 cup of flour. Riemann sums are a definite integral application that can be utilized to estimate the area under the curve using rectangles. There are several different Riemann formulas. There is the left Riemann sum and the right Riemann sum. The left is where the rectangles touch the curve with their top left corners, and the height of each rectangle is equal to the value of the function at the left endpoint of its base. As for the right Riemann sum, rectangles touch the curve with their top right corners, and the height of each rectangle is actually equal to the value of the function at the right endpoint of its base. You can also utilize a midpoint Riemann sum, where the height of each rectangle is equal to the value of the function at the midpoint of its base. The formula is pictured above. However, an easier way to approach it is to determine the width of each subinterval and then find the midpoint of each subinterval as well as their corresponding y values that go along with it, and then to add all the y values and multiply by the width. In addition, you can also utilize the trapezoidal sum, where each trapezoid touches the curve at the top of its vertices. A common misconception is that trapezoidal approximations are Riemann sums. However, they are not. Any approximation that uses rectangles is considered a Riemann sum, and any approximation that uses trapezoids instead is considered a trapezoidal sum in accordance to most resources. Riemann sums are merely approximations, so it's important to determine whether they are over or under the actual value. To determine whether your calculation is an overestimate or an underestimate, you can utilize this visual. First, you have to determine whether the function is increasing or decreasing. If it's increasing, then the left sum is an underestimate, or the right sum is an overestimate. If it's decreasing, the left sum results in an overestimate and the right sum results in an underestimate. For trapezoid and midpoint, you can use concavity. If it's concave up, the trapezoid would be an overestimate and midpoint would be an under. For concave down, trapezoid would be an underestimate and midpoint would be over. You can also take the limits of Riemann sums by allowing n to approach to infinity and creating an infinite number of rectangles that are infinitely thin. And these are the formulas.
The function f is continuous on the closed interval from 2 to 13, and its value is shown in the table above. Calculate the approximation of 2 to 13 f of x d of x using a left-hand Riemann sum with 4 subintervals. It's important to note that in these questions the change in x varies. Therefore, from 2 to 13 f of x d of x, we must multiply 1 times 6 plus 2 times -2 plus 3 times 1 plus 5 times 3 in order to calculate the left-hand Riemann sum. All the values of f of x are on the left. After adding up all these values, the final answer for the left-hand Riemann sum is 20.
Now back to the baking. After preheating your oven at 350 degrees Fahrenheit or 180 degrees Celsius, you want to pour oil and sugar into your mixing bowl. The average value of a function is the average height of the graph of a function. The integral of the function on that interval divided by the length of the interval will result in the average value. The formula is 1 over b minus a, integral a to b of f of x dx.
Calculate the average value of the function f of x equals x squared plus x plus 1 on the interval from 1 to 3. This question involves the average value formula. In this case, a will be 1 and b will be 3. Now multiply 1 over 3 minus 1 by the integral of the function from 1 to 3. Now, 1 over 3 minus 1 is equal to 1/2 times the antiderivative, which is x cubed over 3 plus x squared over 2 plus x. And now evaluate from 1 to 3. Now substitute the 3 and 1 in their corresponding values and simplify the answer, which will result in 22 over 3.
Well, that was boring. Now we're going to mix our oil and sugar with a hand blender. Rectilinear motion is straight line motion that describes the path of a particle. The definite integral of velocity represents the particle's displacement over the interval of time. Definite integral of speed represents the particle's total distance traveled over the interval of time. Rectilinear motion is actually the overlap between calculus and physics, which illustrates the fluidity of both fields. There are a multitude of formulas to use with rectilinear motion to determine specific components of the particle's path. For example, the direction the particle is moving can be utilized with the derivative. The derivative of x, whether it's greater than or less than 0, determines whether the particle is moving left or right, and y prime t, greater than or less than 0, determines whether the particle is moving up or down. And the particle is at rest when x prime t and y prime t are both equal to 0 for the same time t. And the distance traveled by the particle can be determined with the integral from a to b of speed dt. So that's the integral a to b square root x prime t squared plus y prime t squared dt. The position function can be depicted as s of t for a particle moving in a straight line or a linear fashion, and velocity is v of t or s prime of t, whereas speed is the absolute value of velocity, and acceleration is a of t, which is the same thing as v prime t or s double prime t. Differentiating scalar from vector quantities is very important. Speed is a scalar quantity, meaning it only has magnitude, whereas velocity has both magnitude and direction, defining it as a vector quantity. This is why speed is the absolute value of velocity and a constant rather than a vector.
A missile is accelerating at a rate of 14 meters over second squared from a position at rest in a silo 35 meters below the ground level. How high above the ground will it be after 6 seconds? As stated in the question, the acceleration will be 14 meters over second squared, which is expressed by the function a of t. Next, the velocity function will be equal to 0 since it is at a position of rest, which is expressed by the function v of t. And now the position function, which is expressed by s of t, will be negative 35 because the missile is below the ground. Now integrate the acceleration to find the velocity function, which will be equal to 2t squared. Now integrate this newly found velocity function to find the position function, which will be equal to 2 over 3t cubed. Now add this value to the initial position given in the question, which is negative 35. Now substitute 6 into the position function and evaluate. This will result in 109. The final answer for this question will be 109 meters.
Now back to the baking. We're going to crack an egg while we're mixing the oil and sugar with the hand blender. Then we're going to add some vanilla and keep mixing until we achieve a smooth consistency. Definite integrals can also be applied to find the area between a graph curve and the x-axis between two given x values. This area is known as the area under the curve, regardless of whether it's above or below the x-axis. The formula to find the area below a curve is area equals integral from a to b of f of x dx, or the area between curves with f on top and g on the bottom is defined as area equals integral from a to b of f of x minus g of x dx. You can also utilize the same method to find polar area. The area enclosed by a polar curve can be found with the formula area equals integral from theta value 1 to theta value 2, 1/2 f of theta squared d theta, or area between two polar curves, which is area equals 1/2 integral from alpha to beta, big R squared minus little r squared d theta.
Find the area of the region bounded by y equals x squared from the x-axis from x equals -2 and x equals 3. In order to solve this question, we need to apply the area formula. Integrate x squared from -2 to 3. The antiderivative will be 1 over 3 x cubed. Next, evaluate from -2 to 3. After substituting -2 and 3 in the corresponding values, the final answer will be equal to 35 over 3.
And now for the baking. In a separate bowl, we're going to combine all our dry ingredients. Start off by putting some flour into the bowl, followed by baking powder, cocoa powder, a pinch of salt, and mixing it vigorously. Discs and washers are two different methods of finding the volume of a solid, which is obtained by revolving a plane region about a horizontal or vertical line that doesn't pass through the plane. So the volume of a solid of revolution consisting of discs is given by volume equals pi integral left to right endpoint radius squared dx or dy, or the volume of a solid of revolution consisting of washers is given by volume equals pi from left to right endpoint outside radius squared minus inside radius squared dx or dy. It's important to remember to square your values and use pi in these formulas.
Find the volume of the solid generated by revolving the region bounded by y equals x squared and the x-axis on the interval from -2 to 3, about the x-axis. In order to solve this question, we need to apply the volume formula, more specifically the disk method, because the solid will be revolving around the x-axis. Integrate x squared from the interval -2 to 3. This value must be multiplied by pi. The antiderivative of this function will be 1 over 2 x squared. Evaluate from -2 to 3. Substitute -2 and 3 in their corresponding values and then finally multiply by pi. The final volume will be 55 pi.
Cross sections are surfaces or shapes that would be exposed by making a straight cut. The volume of a solid of a known cross-sectional area is volume equals integral left to right endpoint of cross-sectional area dx or dy.
Find the volume of the solid whose base is the region inside the circle x squared plus y squared equals 9 if cross-sections taken perpendicular to the y-axis are square. It is important to note that this question asks for square cross-sections. The area formula for a square is the side squared. Next, solve for the equation for x. X equals square root of 9 minus y squared. A common misconception is students use this value and proceed with the question. This value only represents only half of the square side. Therefore, this value must be multiplied by 2. Now multiply 2 by the square root of 9 minus y squared. Additionally, this value must be squared to calculate the area of a square and will result to be 4 times 9 minus y squared. Integrate this value from -3 to 3 since these are the endpoints of the circle based on the radius. After finalizing the antiderivative, evaluate from -3 to 3. Substitute -3 and 3 in their corresponding values and solve the equation. The final volume will be equal to 144.
Now for the brownie mix. Slowly add your dry mixture to your wet ingredients while blending it in smoothly. Then, grease a pan with some butter. The length of an arc along a portion of the curve is another application for the definite integral. The function and its derivative must both be continuous on the closed interval for being considered for arc length to be guaranteed. Arc length is equal to integral a to b of square root 1 plus f prime of x squared dx.
Find the arc length of the graph of f of x equals 1 over 3 x to the 3 over 2 on an interval from 0 to 5. This question requires the arc length formula. The first step is to take the derivative of f of x. The derivative is 1 over 2 x to the 1/2. Next, substitute this value in the arc length formula, which will be the integral from 0 to 5 square root of 1 over 1 plus 1 over 2 x to the 1/2 squared. After evaluating this integral, the final answer will be 19 over 3.
Back to the brownies. Now pour your mix into a greased baking pan, preferably 13 by 9. Now for the exciting part. Next, smooth out the brownie mixture and place it into your oven. The net change in a function is the definite integral of its derivative. To find the net distance traveled, which is the final position minus the initial position, is the integral of velocity, whereas the net change in velocity, which is the final minus initial velocity, is the integral of acceleration. The formula is integral from a to b is f prime x dx, which is equivalent to f of b minus f of a.
A barrel collects water off the roof of a house during a heavy rainfall. The height of the water in the barrel increases at a rate of r of t equals 4t cubed plus 2t centimeters per minute, where t is the time since the rainfall began. At time t equals 1 hour, the height of the water in the barrel is 2 centimeters. What is the height of the water in the barrel at time t equals 2 hours? This question requires us to calculate the amount of water in the barrel. Therefore, we will take the derivative of the rate of the function to find the amount. After taking the integral of the function and evaluating from 1 to 2, we need to add 2 to the final value since that is the initial value is given in the question. The final answer after evaluating the integral is 20 centimeters.
And now your brownies are finished!